Hello everybody and welcome back. We're going to finish off the 2010 Galois paper in this video with question number 4. And so question 4 here, we can see, it's a lot of triangles. It's got three parts, right? Yeah, there's the end of the contest. So we've got 3 parts here. Looks like we're working stuff out with triangles. If we skim the questions, it looks like we're looking for areas. So, but let's actually read these. So, in triangle PQR, point T is on the side QR so that QT is 6 and TR is 10. Explain why the ratio of the area of PQT to the area of PTR is 3 to 5. Well, we're talking about areas. How do we calculate areas of triangles? And there are a few ways, but the most common way is the one everyone knows, 1/2 base times height. Okay? If you know other things like some of the angles, you can use trigonometry if you know it to get some areas. If you know all the side lengths, all 3 sides, you can use what's called Heron's formula. But I think we should probably just at least start our investigation with something very basic, which is 1/2 base times height. Not everyone knows trigonometry at this stage in grade 10. That doesn't stop the occasional trig question. And not everyone knows Heron's formula. It's a good one to know. And in the right situation, on the right contest, it can really, really push you ahead. But I'm only seeing one side for each of these triangles. And both of them are the base, 6 and 10. So let's try get a height here. And this is what I like. The heights, well, let's get rid of question 3 right now. The height that we could draw for both triangles are both going to come from P and hit QR. It doesn't really matter what the height is, but we'll drop an altitude. Let h be the length of the altitude from P to QR. Then we can see that the area of PQT is 1/2 base times height, whatever that height is. And that's going to be 1/2. 10 times h is the area of triangle PTR. But if we want to talk about their ratio, well, as long as we set up the ratio system, or the ratio symbol in the middle, whatever we do to one side, we do to the other. So we get 3h and 5h. You get to keep the ratio as long as you either multiply by the same number on both sides or divide by the same number on both sides. So let's just divide both sides by h, which we don't know, and we're left with 3 to 5. Exactly what they wanted to show. There's not a whole lot going on here as long as you understand the ratio symbol. And you should, hopefully. So, for example, 3 to 10 is the same as 6 to 20. Just multiply by 2 on both sides. It's the same as, let's say, trying to think of a good one. And then also you can say things like 20 to 40 is the same as 10 to 20, or the same as 5 to 10, or 1 to 2. Dividing by the same number on both sides counts as well. Not adding. Adding won't keep the ratio. Subtracting won't keep the ratio. Squaring won't keep the ratio. It's very, very specific and particular. Okay? It's sort of like another way to write 5 over 3, and then you're just asking yourself, well, what other fractions can be 5 over 3? Well, 10 over 6. And so 6 to 10 is in the same ratio. But you should know ratios at this point. It's something that's definitely covered well before high school. But mention it again, just in case it's something you need to brush up on. Okay, so that's A part, and we have shown why it's 3 to 5. Okay, B. In triangle ABC, point D is the midpoint of side BC. So we get that right there. So those are both the same. Point E is on AC, such that AE to EC is in the ratio 1 to 2. So if you called this X, this would be sort of 2X. Point F is on AD, so that AF to FD is 3 to 1. So we call that 3Y and this one Y. If the area of DEF is 17, determine the area of the whole triangle. Okay. So, looks like they're working with ratios here. So I'll just make a little comment that if you have, say, I don't want to say X, Y, and Z, let's say J, K, and L, and you have this other point M here, and if KM to ML is in the ratio of A to B, then the area of JKM to the area of JML is also A to B. So this is something I would just write off to the side. If you want to, you can prove it. It's the exact same proof that we have in the last part. So call this A times X, call this B times X. The areas are 1/2 AHX to 1/2 BHX. Divide by 1/2 HX on both sides. You get A to B. Very short proof, but it looks like we're going to need this in this particular question. And possibly the next question. And it would have been sort of, it's just a general case of part A. So we have A, B, C. We have D here. Now, I'm not going to use the dividey symbols like that to show that they're the same length. What I'm going to do is I'm going to say that they have the same ratio. We'll put this point here and this point here. Okay, so E and F. So if we just look at E, A, D with this little F here, triangle yeah. So we can say triangle EAF to triangle EFD is the same as 3 to 1. Therefore, EAF, so 1 times EAF is 3 times EFD, but that's 3 times 17, and that'll be 51. And so that tells me that the whole thing, triangle AED, is 51 plus 17, or 68. Okay. So what I'm going to do is I'm slowly going to build up from this small triangle. I'm going to get this triangle, then I'm going to get this bigger triangle, and thus the whole triangle here. Then use the ratio of AE to EC to get this bigger side here, and then use the ratio of BD to DC, and get the whole side here. Okay. So that's the goal. Now I know what AED is. Let's draw a picture again. AE. Don't really need the F anymore. Okay. So now what we're looking at is D, A, C. And we've got E down here. And this is in the ratio of, what was it, 2 to 1? I feel like it was 2 to 1. 1 to 2. 1 to 2. So AE is the shorter one. Okay. Then that tells me that DCE to DEA is the same as 2 to 1. So they're going to have the same common height. I want to avoid writing that argument every single time. So the area of DCE, and if you want to write area in the front, of course, you certainly can. But it's 2 times the area of DEA. But I figured that out. That's 68. So we have 136, I think. Yeah, 136. Okay. What else are we to do here? Wait, is it 136? Get a 6, carry a 1, 12 plus 1. Yeah, 136. Okay. So now then that tells me that the whole area ADC is going to be 136 plus 68. Really testing my multiples of 17 here. 6 and 8 ends in a 4. Carry a 1. 1, 3, 6 is 10, so 0, and then carry the 1 to 2. Okay. We're almost done. AB, this should look like a B. ABD to ADC is 1 to 1, so they're both 204. I'm not going to bother drawing the picture again, but ABD to ADC is 1 to 1. So that tells me triangle ABD has area equal to 204. And ABC, which is just going to be the sum of those two areas, that'll be 408. And that'll be my final answer. The total area here is 408. I wonder if there was a sort of a shorter way to do it. Well, I guess if you say something like... so I said a ratio of A to B for these points. But if you know the one of the areas here, then the total area for that triangle will be A plus B divided by B times the area of the smaller one. And so you'd get 3 plus 1 over 1 times 17, and then times 2 plus 1 over 1, and then times 1 plus 1 over 1. So the 1 dividing by 1 doesn't matter, and you'll get 4 times 3 times 2, so that's 24 times 17, 8, carry the 2. 7 times 2 is 14, so we'll get 168. And then a 24 here, and that'll be 408. Okay. So that would be a equally as good way to do it, I guess. Alright. So, C part. This should be the hardest thing we do on the contest, but, depending on our background, maybe we found 3C to be particularly difficult or something. But for C, in the diagram, points X, Y, and Z are on the sides of triangles UVW as shown. So X is on the UV side, and so on. Line segments UY, VZ, WX intersect at point P here. Nice little intersection point. Point Y is on VW, so that, okay, here comes a ratio of 4 to 3. We know that PYW has an area of 30. PZW is 35, and we want to determine the area of UXP. Alright, so just based off A and B, I'm guessing we're going to be talking about ratios in some way. The only question is, in what way? How are we going to figure out these ratios here? Well, just off... so... I am tempted possibly to have some angle stuff in here, but I feel like we haven't used angles at all in what we're talking about. So I think we're just going to be looking for side lengths and ratios, but certainly it's important to keep all options open, keep an open mind for all of it. But let's draw a copy of our picture, and we're going to see if anything jumps out at us, anything springs to mind. So UV, Z's over here. Was it UV? I feel no, it was UY. UY. W went to X. And V went to Z. And we should really pass through. There we go. Pass through all the same points, so we get point P here. Okay. So we know this is 30, this is 35. And we know we've got 4 to 3. Well, by that same comment that we had, I think I'll try and color code this so it's a little easier to follow. If we just look at this red triangle here, we know one of the smaller bits has an area of 30. So it turns out the area of PVY to PYW is in the same ratio, 4 to 3. So PVY is 4/3 times the area of PYW, and so that'll be an area of 40. And again, if you want to, you can write area every single time. I know when I write a fraction times a triangle, some of you might say, well, you're saying that they're similar triangles. No, I'm avoiding having to write area every single time. So that tells me, we'll keep it red for a second, that this area in here is 40. So we've made that conclusion. Okay. Now, I don't think that we're just going to go sort of around and then get this area and then ultimately get this area. Because the problem is so we've got areas because we have these ratios. But so we've only got 2 triangles that work this way. So we can also say that the big triangle, so triangle UVY to the area of triangle UYW is 4 to 3. But that's the only one that uses Y along the base. That's the problem. So like XVW has VW as its base, but it's not split into 2 triangles. And so I don't think we can use our ratio knowledge that way. Now we've used 30 here, we've used 3 and 4. We haven't used this 35 information at all. So one thing we can do is go backwards and say, oh, I know the ratio of these 2 triangles. Let me get the ratio of these 2 common sides or bases. And I think that's what we need. So if we take a look at W, P, and it was a Z here. The Y goes through here. And it's a V over here. So we have 30, we have 40, we have 35. So ZP to PV is the same ratio as WZP to triangle WPV, which is 35 to 30 plus 40, which is better known as 70. So it's 1 to 2. So ZP to PV is 1 to 2. That's useful. Now, what does that tell me on the big picture? We'll redraw the big picture again, but I think that should start to focus on the other triangles, the ones that we haven't exactly interacted with, including the one that we actually want, which is UXP. So we got 35. It was a ratio of 4 to 3. Now it's a ratio of 1 to 2. We have 40. We have 30. Now what can we say? Well, if we look just at U to P along VZ, UVP to UPZ must have the same ratio, so it must be 2 to 1. I don't know what that 2 to... I don't know any of these triangles here yet. So we might say, let the area of triangle UPZ equal, I don't know, little a for area. So then I've got little a here. Now this whole thing here is going to be 2a. But remember what I originally said, U, V, Y, and U, Y, W are in a ratio of 4 to 3. So therefore, U, V, P, try to make my U's a little more rounded and my V's a little more pointy, has an area of 2a. Okay, that's about as good as we can say, but then, and did I already make this comment earlier? Okay, yes, I did make this comment here. So now what I can say is, I can set up an equation. I think I can solve for a. So 3 times UVY is 4 times UYW. But that's going to be 3 times 40 plus 2a is 4 times 30 plus 35 plus a. So we'll get 120 plus 6a is equal to 30 and 35 is 65 times 2 is 130 times another 2 is 260 plus 4a. So 2a on one side, 140 on the other. A is going to be 70 again? Really? Okay, I suppose. That would make this 180. And this would be 135. Yeah, okay. That's not a problem. Alright, so A is 70. What does this tell me? Does this tell me anything worthwhile? I feel like there might be one more ratio I need to work out. So we got 70 up here, we've got 40 down here, 30, 35. What could it possibly be? So do I need to call this B and this C now? I'm looking. So we need to figure out what B is. But I'm just having trouble trying to figure out what is what the final step is. I'm so close. I need to be able to separate these two. So I know B plus C is 140. I was doing so well. I had so much momentum, and I seem to have lost it. So, okay, I wanna try and get B. So I wanna deal with sides that have B on them. That's the new task. Now the question is, can I get one that has B and only a few other bits? So I can figure out the ratio. So this ratio is 2 to 1 on that side. I know this is 4 to 3. I don't know what the ratio of B to C is. But I know, so B to C is the same ratio as B plus 70 plus 35 to C plus 40 plus 30. Yeah. Do I want to write that up anymore? I'd say it's clear, but what to do? Yeah, so here's what I'm going to say. We'll redraw the picture with my letters intact, just because I want to show how I would probably try and write this up. So you get the X here, Z here, Y there. All right, so UX. So we'll call this. So we'll let. If you're gonna have a variable, let give it a name. So we might say let the area of UXP equal B, and the area of XPV equals C. So then, by considering this triangle here, P, U, V, X, UX to XV must be the same as B to C. But then, by considering the bigger triangle with W at the top, we get B to C is the same as triangle WUX to triangle WXV, but that's B, a 70, a 35, a 30, a 40, and a C. So that's a B plus 70 plus 35 to C plus 40 plus 30. Okay. So that tells me C times the one side must be equal to B times the other side. And you'll get, we'll get CB, or I guess I should say BC, not a problem. This BC and the other BC are going to cancel out, but we'll get 70 and 35 is 105. So we'll just write 105C. Must be the same as BC plus 70B. Those two cancel out. So 105C is 70B. Or another way to say that, divide both sides by 7, you'll get 35c is 10b. Divide both sides by 5, you'll get 7c is 2b. And I guess you can say that c is 2/7 b. We want to solve for b. Now we know that 140 is the area of b plus c. But now that's b plus 2/7 b. So that'll be 9/7 b. And yeah, so that'll be... The problem is this isn't an integer, and I was really expecting this to be an integer. But that's okay. Oh, this isn't... What am I doing? I divided by... Yeah, so 105 divided by 7 is not 35. It's 15. Divide both sides by 5, you get a 3 here. This is a bit more comfortable. So 2/3 here, 2/3 here, and that'll make it 5/3 overall. 5/3 b. Okay. And then we multiply by 3, so that'll be 420. Divide by 5. That'll be the same as b. And that's going to be b is 84. And you could even double check what would c then have to be. Not that we care exactly what it is. We've got our final answer. But a little double check, because you'll notice there I made a little arithmetic mistake for a second. Until I sort of... I would expect with all the integers we've got and the nicely chosen numbers to have an integer final answer. That's why I was a little suspicious of that 9/7. It just seemed wrong. So I went back and double-checked my arithmetic really quickly, and yeah, I was wrong. 35? No, it's 15. 15 times 7 is 105. What would my c value be? It's going to have to end in a 6, and that'll carry this up to 90. So it'll be 56, and that is indeed, if I divide that by 2, or sorry, if I multiply this by 3, I get the same as 84 multiplied by 2. They're both going to be 168. Alright, so that works out nicely. If you wanted to, you could even double check that 84 plus 70 plus 35 had the same ratio, that is 3 to 2, or 2 to 3 as 56 plus 30 plus 40. That'd be fine, you could go ahead and do that, but I'm happy with my answer. A little therefore statement of therefore UXP has area 84, and we're all done. Okay? So that finishes off question number 4, and thus that finishes off the whole contest. Thank you guys for joining me. Another Galois will be up in the future. Stay tuned for the 2010 Hypatia, which I'll be posting. That's another written contest. And yeah, thank you for watching. I'll see you next time.